The only thing that evolves faster than technology is our expectations. We want everything. Better, easier, now. Suddenly, downloading an app feels like it takes forever. And in many parts of the world, data is still at a premium, with 1 megabyte costing up to 5% of a monthly wage. Let's face it though, until now, the alternative to native apps hasn't been great. But that was then. Progressive web apps can now deliver mobile web experiences with a native look and feel, offering features like real-time push notifications, adding a site to your home screen so you can easily jump back to it with a single tap, even when you're offline. Plus the ability to make quick payments on the go. And all from your browser. This is the next generation of the mobile web. So what are we waiting for? Let's go and build something great.
Good afternoon, everyone. I wanted to start with this video to get you all excited about the future of web apps. My name is Joubran, and I'm a full-stack teacher in Amsterdam and Brussels, and also a technical consultant. So the future of web apps. Today I'm gonna give you a PWA refresher, so just like a 5-minute intro to progressive web apps, because I know there was another session for progressive web apps, also workshop. And then I'm gonna give you some best practices that go well with PWAs, and even if you're not using PWAs. So the best practices for the modern web. And also we're gonna see some modern web APIs. And finally, I'm gonna show you how all of this converge towards the future. So let's start with a PWA refresher. And the way I like to think of a PWA is to say this is an ongoing solution for the problems of the mobile web. So the web is slow, and the mobile web is even slower. And progressive web apps aim to solve this. So this is an ongoing solution because it's not something fixed. It's still in development. So this is how your users can add a PWA to the home screen. So once they have this icon on the home screen, the browser UI doesn't show anymore. And this gives the user an immersive experience. And all of this can be configured through a manifest file, a manifest.json file, which gives you some key value pairs where you can specify the short name, theme color, background color. All of them are fairly standard, simple, except for the display standalone. This is the most important one. This is the one that hides the browser UI. And then you also have service workers. And traditionally, this is your page, and this is the internet. And you have a network request, which goes to the internet. And then you get the response back. But once you install a service worker, you'll be able to intercept those requests. So the service worker acts like a proxy, which intercepts network requests when they're going to the network and when you get the response back. And this is very powerful because it lets us do a lot of cool things. First of all, we can make our apps work offline. We can also receive push notifications, and we can also do background sync. So how do we register a service worker? First of all, it's not supported on all browsers, so let's make sure there's support for it on this browser. And then we register a service worker using the register method. And this file normally has to be on the root level. If you put it inside like the scripts folder, you'll only be able to intercept requests going out of the scripts folder. So this is like a security feature. And this is a regular promise, so you can resolve it or you can catch if there was an error. But how do we write service worker code? You can research on the internet and see that you can actually write it yourself, but it's not really recommended. You can use a library such as GoogleChrome sw-precache. So this is a node module that lets you configure it and say, I want to have the index.html, and I want to have all the images inside the images folder to be part of the precache, which means as soon as the user registers the service worker, I need to have these in the cache. So for the next time the user opens this page, I can reliably serve them. So then you run the node module, pass in the configuration file, and you will get the service worker JavaScript file. So here's how it looks like. So now we have the cache, and we can decide to completely bypass the internet because we have the stuff in the cache. And we return these information reliably and consistently to the user. So regardless if the internet is slow, if we're offline, and this is the power that service workers gives us. So before, to ship the index.html and those images, we had to go to the internet, which is okay for the first time, but on subsequent requests, we might not have good internet connectivity, or we might be offline. But now, we can actually ship those reliably from service worker. So this is the thing that you achieve by using sw-precache. And that's only half of the way, because after your app has loaded, you want to talk with some APIs, and you also want to manage the cache for these. So that's why you can use sw-toolbox, which gives us dynamic caching strategies. So the three most popular ones are cache first, which is if you know something's in the cache, let's read it from the cache. Network first means go to the network, but in case something wrong happens, just fall back to the cache. And this is a powerful thing, because previously if something failed, then it's the end of the world. But now we can have fallback strategies. So network first, but if it fails, go to the cache. And fastest, which traces both the network and the cache, and returns the first response to the browser. And in the background, if you have the network request taking more time, it will actually update the cache for the next time you use it. So we call it stale while revalidate, because you're showing content from the cache, and at the same time, in the background, keeping an updated version for the next time. So, and you use sw-toolbox with sw-precache at the same time in the same configuration file. And this is on a route basis. So you can say, I want the API countries, this is a regular expression, to use the cache first strategy. And you can say, I want anything that starts with API v1 to use, for example, the fastest strategy. And if you've been following along the work of service workers, there's a newer library called Workbox. But it's almost exactly the same as sw-precache and sw-toolbox. It's just more modular. So if you already have work on sw-precache or toolbox, it's okay, you can keep it. But if you're starting from scratch, this would probably be a bit easier and more modular, so no big deal. And for browser support, which I know is probably the most interesting thing, everything works on Chrome. Progressive web apps work on Firefox as well. Opera, they also work on Samsung Internet, which is quite interesting. So on my Nexus device, I have Samsung Internet and Chrome, and I added the same progressive web app using those two browsers, and you cannot tell the difference. That's a nice thing about standards. For Edge, service worker support is right now behind a flag. That's because they're working on it, so we should expect it soon. And for Safari, there isn't any public information except a brief positive signal in the next 5 years. So what you can do for iOS at the moment is just a couple of things. You can add like a fallback meta tag or a vendor-specific meta tag, which is the Apple mobile web app title. And this allows you to have the same effect as the manifest title. And you can also do the full screen experience, which surprisingly I think was supported for the last 4 years. But I would say proceed with caution with this, because some users have reported that their app was slowed down. And another important UX factor is that if you don't test on it, there's no hardware back button. So your users might get stuck there forever. And you can also change the status bar style as well. But if you're going to do these two, make sure to test on iPhone. So that was the PWA refresher. Now let me show you some best practices. And just like I told you, PWA is between parentheses, because even if you're not doing PWA, these things make a lot of sense for the modern web. So the first thing we're going to see is the theme color. And the theme color is different than the manifest theme color, because we're not a PWA yet. We're still in the browser. And this lets you theme the URL status bar here, the URL bar, and the Android status bar. So to do this, you will have to use the meta theme color and give it a value. Now, typically, this value will be the same as the one you would have in the manifest, but you would still need to have this kind of thing, because at this stage, we're not a progressive web app, so the manifest.json doesn't actually work. And then the next tip is to optimize the first paint, which means to get pixels on the screen as fast as possible, because that's a common pattern we see on native apps. You open Facebook, you have something that shows up on the screen almost immediately. But for websites, we're typically used to see a wide screen for a second, 2 seconds, 3 seconds. So it's important to optimize the first paint. And one way to do that, one recommendation is to inline the most important pieces of your CSS in the head. So you could do this manually, or you could use critical CSS node module, but make sure to keep it up to a certain limit, say 200 kilobytes at most. And for the rest of your CSS, you want to load them in a manner that doesn't block rendering, because you don't want to have this white screen. And to do that, and the latest technique is to use the link rel preload. Has anybody used link rel preload? Yeah, great. So this allows you to load the CSS in the background without blocking. And you have to say that this is a style. And once it loads, you basically change the relationship from preload to style sheet. This works on Chrome. There's no support for other browsers yet. So meanwhile, you can use the load CSS script in polyfill, which can be inline because it's really tiny. And for JavaScript, if you want to unblock JavaScript for the same reason, you can use the async attribute, which is going to let you reach document ready as fast as possible without having to block on those scripts. And if we take this concept a bit further, we can talk about the app shell architecture. Has anybody used it before? So the app shell architecture is the minimal HTML, CSS, and possibly JavaScript that powers your user interface. So here's an example. The app shell is on the left. You can see we have like the container of our app without the content. It's like when you open Facebook in the first 300 milliseconds, you see the header, you might see the sidebar, but then you don't have any content. And then once the content has loaded, it just populates the view. The reason why this pattern is important is because we have it on native apps. So same thing for native Twitter or native WhatsApp. As soon as you click, you get something on the screen. And this is, for example, an example of an app shell. It doesn't need more than 30 lines of CSS of code. The CSS code is not important, but it's to show you that this actually works well with inlining styles in the head. And the last important bit of the app shell is don't forget that this is about critical code prioritization. So you decided that this HTML and this CSS is important, is critical. So I'm going to put it in the head, or I'm going to inline it. But you should sometimes do the same for JavaScript. If I go back to this example, there's a functionality here. So if we don't prioritize this JavaScript, and so your user is going to click on this for the first 3 seconds without having any response back. So in this scenario, it makes sense to have the part of JavaScript that opens this side menu as part of the app shell as well. Now here's the tricky thing. We're talking about performance and modern web apps, but at the same time, we want to load web fonts. And this is probably tricky. How can we have like a decent font on our app or web app without actually having a problem with performance? And the trick here is to actually use device fonts. And this is similar to system fonts, but with a tiny difference. So first of all, you know that web fonts are really heavy. Even if you use Google Web Fonts, even if you inline them in the head, they're going to be heavy. So, and system fonts are weightless because they're available on the system. So if you use Arial, I'm not saying you should use Arial, or Comic Sans, or System, they're going to be almost free to use. And this is what actually Medium does. Here's Medium on iOS. They're using San Francisco, which is the device font on iOS, and on Android, they're using Roboto. So first benefit is that they're weightless. Second benefit, as an Android user, I'm used to see Roboto everywhere. So this feels more like a native app. And for iOS, I'm also used to see San Francisco. So how can we do that? So it's actually this kind of font family that you can use. So you can start by looking, do I have, for example, San Francisco on Safari and Firefox? If this doesn't work, then we're going to revert or fall back to this one, which looks for San Francisco on Chrome. If it doesn't work, then we're going to look for Sego UI for Windows. So for example, if you're on Ubuntu, you're going to end up having the Ubuntu font because it's going to try one after the other. So this is a nice trick, and we saw that it was also used in Medium. But still, sometimes you still want to use web fonts. So for example, you can decide to use device fonts and also web fonts. And when you want to use web fonts, you actually have to preload them. So let me show you what the problem is. Typically, you have without preload, when you start loading the index.html and the CSS, even though the browser reads that you have an @font face declaration, it's not going to load the font. That's because browsers are afraid that the developer ends up loading 10 fonts and not using them. So the browser will only start loading them when it's confident that you're going to use it. But this ends up having a flash of unstyled content, because we have the content here, but we don't have the fonts. So we actually want to shift those two to the left as soon as possible. So how can you do that? Once again, with link rel preload. So you preload those font files. You say, I'm 100% sure I'm going to need those fonts. But make sure there are some gotchas here. Make sure to specify the type of the font. So you don't want, for example, Safari to preload WAF2 if they don't support WAF2, for example. And make sure to add the cross-origin attribute. If you don't, you're going to end up preloading it and then loading it again, which makes it worse. And a typical pattern you see on the internet is like the typical code you see for registration of service worker is just the one I showed you before. But I'm going to show you that this is problematic a bit, and it's better to delay it. So first of all, the first time your users are loading your page, you don't have a service worker because it's not installed yet. So you can only rely on optimizing the first pane to have a fast experience and on the app shell pattern. But you can probably not do a lot more. On subsequent requests, you may have service worker if it's supported on the browser, which is great. And this means that here we should be really focusing on shipping something as fast as possible, because we're relying on the network to get all of these resources. So let me show you what happens if you're doing early registration. So if you're registering service worker as soon as possible. The problem here is that this is the index.html, this is the CSS, and these gear icons, these are interleaved service worker requests. So instead of letting the browser and the network focus on having a fast first-time experience, you're actually degrading it because you're registering the service worker interleaved with this first load. So it would be best to actually delay all of these until the first page has loaded. And to do that, you can simply just wrap it in a load event. So make sure, the window has loaded. So after the window has loaded, after you've loaded all of these things, you can actually register the service worker. And this basically compares to this graph, where in the first few seconds, we're just completely focusing on shipping those critical resources, and afterwards, we can set up the service worker. But if you're using a framework, and you're most probably using a front-end framework, if you do this, it means you're racing your own framework, because the framework's probably running things on load. So it makes sense to actually defer this until your framework has completely booted. So you probably have a callback, which means React has finally done, or Angular as well. Now, for the next trick, so there's a web API that lets you know when the user goes online or goes offline. So who thinks it works everywhere? Wow, nobody? It actually works on IE8. So if you open browser support, it has support like on all browsers back to IE8. So this is a really good and old web API, and it makes so much sense to use it right now with progressive web apps. So let me show you why. You can actually do this kind of experience, where as soon as you go offline, we dim the entire UI, even the theme color here, to show the user that you're offline, but you can still use the app, but it's kind of a conservative mode. You may not be able to do everything. So how can we do this kind of thing? It's fairly easy. You just want to listen for the online and offline events on the window object, and you can call your own custom methods. For example, online mode and offline mode. One consideration, though, is since you may be building a PWA, your users can open your web app while they're offline originally, and this is not going to fire the offline mode. So that's why you have to manually check for it. This is a capital L here, and see if we are already offline, I'm going to call the offline mode. So what can you do inside of this offline mode? You can find the theme color, the meta theme color that I talked about, and you can actually change the color for it to gray. And you can add this class offline to the entire body. Is anybody using CSS variables? Okay, so let me show you a cool trick you can do if you're using CSS variables with this one. Assuming you have a CSS variable primary, which is like your brand color, assuming it's red here, and you have the offline color, which is gray. So once the offline class gets added to the body, you can actually flip those two. And that's a nice way to do the video that I showed you. So you can dim the entire UI to show the user that you're in offline mode right now. All right, and the next step to know about is debugging. So debugging is critical when building modern web apps or progressive web apps. And the first part of it is that you can inspect the manifest in Chrome DevTools. So you can right-click, inspect, and open the application tab, then manifest. So this is the manifest for Twitter Lite. It's good because you can inspect it without having to use your phone every single time you make a change. You'll know if the icon's working. You'll know if you're missing any fields. You can also inspect service workers. So you can stop them, update them. You can also send a push notification, like a test push notification, which is very convenient. I'm not even sure if this is possible on native apps. You'd have to set up all the certificates and send a real push. You can also emulate background sync, which is really handy as well. Is anybody using Lighthouse? Yeah, this is one of the best, this is the best Chrome extension or any piece of software that you have to get progressive web app metrics. And even if you're not building progressive web app metrics, you get metrics for performance, accessibility, and best practices. So this is a must-use no matter what kind of web app you're building. So it guides you, it will show you things that we've never seen before. And it's like a checklist that you can always keep. It's also available as a node module. So if you want to integrate it as part of your continuous integration, it lets you get performance regressions automatically. And as of Chrome 60, so the next stable version of Chrome, is going to be available in DevTools. So I think it'll be easier for us to use it as well. So let's talk a bit about getting an icon on the home screen. So assuming you've made it to the home screen, that's a big step for you. And your users don't really know that there's a term called progressive web apps, at least most of them. If they have something on the home screen, they expect it to be fast. So you have to meet their their expectations of performance. And there's a typical question that I always get. Can I make my website as a PWA? So it's kind of a generator. So technically, you can make any website on Earth as a PWA. But that's probably not going to be a good idea. Because if the performance suffers, then you're going to have an icon that opens a wide screen for 6 seconds. And the app's going to be slow. Scrolling is going to be slow. So what you can do, in case you have like a legacy app, for example, like Twitter had, you can, I know nobody likes this term, but you can start from scratch and do the basics. Twitter has done it, and even Uber has done it, I think like 5 days ago. They released an awesome web app. You can go check it out at m.uber.com. So you can take a progressive approach and only add the critical features step by step as you get more feedback. The reason why I'm saying this is because even if you're able to ship the app shell really fast, after the app shell itself is not really useful. It's just like an indicator that the page is loading. After the app shell, the users are waiting for the first meaningful paint. For the first time, they can actually see something useful on the screen, like the products. But even when they see them, they cannot interact with them. Do you know why? Even if they're online, why? JavaScript. So on most websites on mobile, you have JavaScript blocking the main thread for up to 8 seconds. This is a real trace that I took from this MacBook Pro i7 with 5x CPU throttling, so emulating a mobile device, and 3G throttling from nasa.gov. And it takes 8.25 seconds to just parse JavaScript. So the reason behind it is because they're probably shipping like a 1 megabyte JavaScript file. So shipping less JavaScript is a trend, is a good thing to do if you're building performant mobile web apps, regardless if they're PWAs or not. And I know this is one of the hardest things, so I crafted some tools that will actually help you, some recommendations. So has anybody used Source Map Explorer? So this is a node module that actually reads your vendor JavaScript map, the map file and tells you how much, the percentage of every library inside of it. So this has helped many teams understand why they're shipping the same library twice with different versions. Or if you're shipping, for example, Lodash, which is taking up 20% of your app, but you only need 2 methods out of it, then you can maybe just include those 2 methods. So this is this is a good idea to know if you're shipping more than you actually need. Code splitting is also one. Code splitting is also one of the best strategies to go about this, because even if you're not using a framework like at all, assuming you're using web components, no polyfills, nothing, once your app grows large enough, you're going to end up with a 1 megabyte JavaScript file, and there's no way you're going to make this fast. So the only way to make this fast is to actually code split it. So I really like the way Uber did this. I just read it yesterday. They only ship initially the JavaScript file that lets you order a ride. If you want to edit your information, payment information, they would actually lazy load this only when they're needed. So there's no need to ship the entire JavaScript bundle when you only want to let the user request a ride or login. And this has become easier with Webpack too if you want to do code splitting. Anybody used code coverage? Not like PHP code coverage, this one. So this is a new tool that landed in Chrome DevTools as well. It lets you record a trace, so you record and you go to a website, scroll down, interact with the menu, and it lets you know how much of your JavaScript is not being used, how much of your CSS is not being used. So this is extremely helpful when you want to optimize for the first experience. And the common thing I see when we're using modern web APIs is that we always load polyfills. So for example, if you have a polyfill for fetch, which is like 8 kilobytes, we're always loading this polyfill, but 90% of the browsers already have that. So I was doing some kind of experimentation, and you can find it here on Promifil on my GitHub profile, which basically lets you define your own polyfill, so you can load to whatever polyfill you want, and you can run it with a test. This says Promifil. So you give it the test, is fetch supported in this browser? If this is going to return true, then this promise is going to resolve immediately, and it lets you use fetch directly. But if fetch was not supported on this browser, then this promise is going to block until it's actually loaded the polyfill and executed it, and then it lets you run this fetch. And this makes a lot of sense to use with fetch itself, because fetch is like jQuery Ajax, but it's native in the browser. And all browsers have it right now, except maybe the older version of Safari. So 90% of your users have it. There's no need to always ship polyfill. So here's how it works. So for browsers with fetch support, you will have the index.html, which loads the JavaScript file, which then executes fetch and loads the users.json without blocking, without taking any hit. But for browsers without fetch support, you can see between the JavaScript file and the fetch request, there's this blocking here. It's a bit slower because I'm using throttling. And this lets the polyfill load only when it's needed. So this is what I mean by conditional polyfill loading. So you're all using JavaScript frameworks or libraries. Nobody's building anything from scratch, and this makes a lot of sense. So this is why I crafted a set of requirements that I personally look for when I'm looking for a front-end framework. So it's not a comparison between all of them, but a set of rules, or a set of guidelines. So first of all, I always look for a smaller bundle size, because if my framework is taking 150 kilobytes already, or maybe 100 kilobytes, that's already too much. This is going to take like 4 seconds to run on old mobile devices. So I don't have any JavaScript that I can run in order to be able to do a good experience. Another thing is the ability to code split, because even if the framework was 3 kilobytes, eventually I'm going to end up with a 1 megabyte JavaScript file. So I want to be able to do code splitting. Also, there's something that I call platform leverage, or that's called platform leverage, which means there's no need to reinvent web APIs that recently landed in the browser. And the most common example that I just showed you is fetch. So there's no need to have like a library to do fetch requests or Ajax requests, because we have just a tiny function that's natively supported in the browser. And when it doesn't work, you can simply do conditional polyfill loading. So Polymer 2 actually does conditional polyfill loading. I'm going to talk about it later on. So who's using React? So recently with React, you can use the create React app, and this is going to give you a PWA by default. which is a great starting point because you don't have to edit Webpack or anything. It's just work. Has anybody heard of Preact? Okay, so Preact is a React alternative that's only 3 kilobytes. So it's the same API, but it's only 3 kilobytes. Uber is actually using Preact, and the nice thing about it is that the framework ends up being like 3 kilobytes, and your app size ends up being bigger than the framework itself. It's worth noting, though, that Preact is 3 kilobytes in ES 2015, so when you transpile it, it's going to be a bit bigger. You can also generate a PWA by just using Preact command line. Anybody using Vue? Yeah, so for Vue as well, you can use the PWA template, and this is going to give you a progressive web app out of the box. Anybody using Angular? So Angular 2, 4. Okay. There's this mobile flag, which is currently disabled. So, but you can work around it right now. You can build for production with ahead-of-time compilation. And then this doesn't really exist, but you can build it yourself by using the precache, sw-precache, and sw-toolbox. So this is like an npm script that you can do to produce all of these things. So to produce the service worker. Anybody using Polymer or Polymer 2? So I did some experimentation with Polymer, and what I really liked about it is that on Chrome and Safari, it's only 11 kilobytes, which is really small. The reason behind it is because it's using web components, and web components are native in Chrome and Safari. So once again, they're using conditional polyfill loading. If you open on Firefox, it's going to be, say, 25 kilobytes. If you open on Edge, it's going to be 30. If you open on Internet Explorer, it might be as big as 50. But that's the thing. If you're on a newer platform, you don't need all of these JavaScript. And most users on mobile are actually on Chrome or Safari, so it makes a lot of sense to use it. So now let's take a look at some modern web APIs. And this is completely independent from progressive web apps. But once again, if you're doing a PWA, you may find yourself using those web APIs. So has anybody used passive event listeners? So I want to tell you something. As soon as you add a touch move event to your page, you're actually making it slower, like much, much slower. And that's not your fault. That's the fault of the API itself, of how the spec was designed a few years ago. So the reason behind it is because you can actually cancel this event. So you can do event.prevent default. So the fact that you can cancel it makes it slower. Let me show you why. Here's, for example, a user doing a touch event on your web app, which gets picked up by the compositor thread and then reaches the main thread, which is going to call the onTouchMove event, which is going to call your own function, your own callback. So it's going to call your function and see if you called event.prevent default. Assuming you did not call event.prevent default, it's going to bubble up to the compositor thread and then finally commit it to the GPU. And this is when scrolling happens. So why can't we go directly to the compositor? Because we need to know if you canceled this event. And this means during this entire time, scrolling is blocked. And this is terrible. So this is why I told you this is not our problem. This is an API problem. This is why we now have this passive true, which basically you're saying, I'm not going to cancel this event. And even if you cancel it, it's not going to do anything. And this basically lets the browser short-circuit the entire thing and directly commit to the GPU. So to see the difference, there's this video which actually shows you on the left how it used to be, and on the right how it got fixed. Slow motion's even worse. So however, I want you to know that this is only the case for touch events and wheel events. So if you have a click event or like all the other events, don't worry about it. And as of Chrome 56, Chrome started doing it automatically because 99% maybe of touch events were not supposed to be canceled. So they made them passive by default. But it's good for us to know about it because we want to make good experiences for Safari, Firefox, and other browsers as well. Another web API lets us defer non-essential work. And a typical example here is you have a button that triggers an animation, and you also want to send analytics. But so you're sending analytics, doing animation. This ends up making the animation much slower. That's why there's this new web API, request idle callback, which lets you schedule non-essential work. So you want to do some kind of work, but not exactly right now. This lets you schedule non-essential work in small callbacks. And the browser will only call it when the browser is confident enough that it's going to have some free time before actually syncing again on the screen, before drawing a new screen. And this basically makes sure that all of these vsyncs happen every 16 milliseconds. So you end up having 60 frames per second every time. So this is good for analytics or any kind of flogging you may be doing on the on the front end. And this works right now on Chrome and Opera. There's also intersection observer, which is really interesting, but browser support is still limited to Chrome, Opera, Edge, and I also saw that it's coming to Firefox soon. So this basically lets you ask the browser about the visibility of a certain element. So you can tell the browser, tell me when this element becomes visible on the screen. And this is how it works. So you define an intersection observer, which returns a list of entries. And then you check the intersection ratio. I'm going to check it for the first element only because I only have one element, for example. And if its triple equals 0, then the element is invisible. And in other cases, it's visible. And then finally, you decide to observe actually an element, for example, ID box. So it's that simple, but don't forget it doesn't work on all browsers yet. And why I think this is cool is because it lets you do infinite scrolling much easier. So you discover the visibility of, say, the last element, and this will let you trigger the load more method. I think Twitter Lite is using it to do lazy loading of images. So because they're working with long feeds, they don't want to keep the images always in memory. So they can actually remove images that become off-screen, and they can load them once they become on-screen. And I think this will only be case for ad libraries. It only means that once it's supported, ad libraries will be able to discover advertisement visibility much more efficiently than having to actually hug the scroll events on the window. But if you're deciding to do any parallax, don't use intersection observer. So this is not meant for low latency scroll dependent animations. There's also an exciting, this one is PWA specific feature, which is background sync. And there are two sub-features inside of it. The first one works on Chrome, and this basically lets you schedule, it waits for connectivity and employs an exponential backoff, which means using this one, you can let a user send a message, close your app, close the browser, and when they get back online, your message will be sent. So just like you can send messages on WhatsApp offline. And it's going to retry every second, 2 seconds, exponentially. And the other one, periodic sync, which is currently being spec'd, so it doesn't work on any browser yet. It lets you, for example, load content every 5 minutes in the background, and even if your app is not open. So for example, every 5 minutes, I'm going to get the latest news. You don't have to specify those two, but this basically, you can constrain it to be on Wi-Fi and to be plugged on a charger. There's also CSS containment, which makes a lot of sense with web components, because previously, once you changed the left property or the width property of an element, the browser had to recalculate the style for the entire page, which doesn't make any sense. So this could take, in worst case scenarios, up to 1 second, because the layout route is scoped to the document. But right now, you can use the contain layout, so you can specify or constrain the containment to this element, and such layouts changes actually become much, much faster. There's also the payment request API, which works on Chrome for Android, soon coming on all Chrome platforms. So on the web, on Mac, on Windows, on Linux, and even on iOS, I think. So this is not a payment processor like Braintree or PayPal. This is basically just a native UI that shows the user his already saved credit card, his already saved address. And if you want to use this, you can basically check for its support and have the flow if it's working. If it's not working, you can simply redirect back to all of these legacy payments. There's also the WebShare API, which is behind an origin trial. So it was being tested with a few websites. So it's not available anywhere right now. But it basically lets us share, so open the native share dialog on Android. Right, so, and this is where we come to the future. So although most of these web apps are not supported everywhere, so these are kind of the future, but I also want to show you why the future is even more promising. And the first one of them is the improved add to home screen on Android. Let me show you. So I was able to record this on Android Chrome beta, I think, but behind the flag. So once you add the home screen, it's going to take some time because it's being tested at the moment. You can see here it's installing. So it's installing a web APK. And now, even if you close everything, rather than having like a home screen icon, you can actually remove it, and you will still find it in the app in the app directory. You can even inspect this app. So this is like a real app right now that's packaged by the browser, which is a progressive web app. So once again, this is only behind the flag right now. Not everyone has access to it, but you can check it out on Android. And you also have some experimentation for PWAs on desktop. So for example, Chrome OS right now has the same flow you have on your mobile. So you can add to shelf, and this is going to open Chrome without its UI. Also, Windows 10 is doing the same. So they're also finding all the progressive web apps on the internet, indexing them, and putting them as part of the Windows 10 store. And if you install it, it's going to be much faster because you're just installing an index.html file. And how many of you have heard of WebAssembly? WebAssembly. Great, so this is really exciting. This is a cross-browser effort. It's supported on all browsers, some of them behind the flag. So this is a new language that runs in the browser, and it's designed to run native C or C++ code. This is an example of a method called add2, which adds two numbers together. It's not the most exciting scenario example, but let me show you. So this is how you can use it. I'm using async await functions to async await to make it easier. So you fetch the WebAssembly file, convert it to an array buffer, create a module of it, and create an instance. And then if you console log instance.exports, what you're going to have actually is a native add2 method in your browser. So just like new promise is a native method in the browser, I was able to export my own add2 method. And the reason why this is really exciting is because this is what I think the future app model is. You have your progressive web app or your mobile web app, and it's going to do awesome things because of WebAssembly, because you can do like heavy lifting using WebAssembly. So this opens up the door to image and video editing, image recognition, encryption, and so many things we've never thought we were able to do on the web. And actually Figma, which is a sketch-like editor on the web, started using WebAssembly for image editing. So I still have just maybe 1 minute. So did I get you excited about the future of web apps? Yeah, great. Okay, so I have to call to action to you. If you go to speedtest.net, they actually tell you, thank you for coming to our website, but we cannot do it on the web. You have to install 15 megabytes to test your internet speed, which doesn't make any sense. So if you want to build your first PWA, I would recommend to get rid of your business logic first, build the PWA from scratch so you can know how it works, and then rebuild it or just add your business logic as you go. Make sure to always plug and test. So because what takes a fraction of a second on your laptop could take up to 5 seconds on a real mobile device. So always have your phone plugged. If you're on Chrome, use Android. If you're on Safari, use iOS, or the opposite. And use throttling features in Chrome, so you can throttle CPU up to 5 times, and regular 3G if you're working on desktop. And it's always good to see that other players in the market are doing that. So you can check out twitter.com on mobile. They have an awesome PWA. I uninstalled their native app, and I've been using it for a few months. There's also Wigo and Flipkart. And don't forget that there are also other solutions for this problem, the problem of low internet connectivity and low devices. And progressive web apps is one of the many solutions, and other solutions could be Android Instant apps or Android Go. So it's not like one of them is going to win. I think all three will remain and will get stronger because they have different approaches. So I've used Google Web Fundamentals and Mozilla Developer Network to craft this talk. You can check it out as a resource. You can also find the slides here. You can also find my Udemy course on becoming a better developer here. And I hope you enjoyed this talk. You can ask me questions afterwards.